Morning Calc students, for the next several minutes, I'm going to attempt to provide some solutions, maybe not full solutions, but hopefully enough to get you by for a few problems that were requested from sections 5.1 through 5.3. For the next 24 hours or so, if you have others, of course, let me know and I'll try to get these videos set. I'll probably break this up into two quick videos. I'll go rather quickly, but you can always take another look at them if you have some questions. The first one is from section 5.1, number 52, and there are a variety of questions we have. This function that we see in the orange is the derivative function, so that's very important to remember. Part A asks us to find the slope of the actual function at 4. Well, at 4, the derivative is obviously negative, and it looks to be -1. So for part A, the answer is going to be -1, because that would be the slope, which is the derivative, at 4. For part B, it asks if f of 5 minus f of 4 is greater than 0. Well, it turns out that the f of 4 minus the f of 5 is not greater than 0. It's actually going to be less than 0. The reason being is the original function is decreasing on this whole on this interval from 4 to 5 because the derivative is negative. So if the original function is decreasing, what that means is that f of 5 is less than the f of 4. So we take something minus something bigger, we should get a negative number. For part C, we basically are looking for when the original function has a maximum. There is a maximum and x is approximately 3.5. The reason is the derivative goes from being positive to negative. So the original function is increasing over here and decreasing over here. And then finally part D, we get the function, the original one being up from -infinity to 1, and then from 5 to infinity. It's down from 1 to 5. Now what this means, again, is that we know a function is concave upward when its derivative is increasing. The derivative is increasing all the way up to -1, or +1. Then the derivative is decreasing between 1 and 5. So where the derivative is decreasing, it has to be concave downward. What that then means is there is a point of inflection at x equals 1 and 5. Now, we don't know the y values. What we're leading to is that we can actually get a sketch of what the original function looks like if we wanted to, but that's not really the point. We do see this derivative is a third degree. So the function that came before it would have to be a fourth degree function. And here are all of its characteristics. So that's problem number 52 from section 5.1. 59 from the same section involves some physics and some differential equations. The acceleration in 59 is given as -32 because it's in feet per second per second. We know the velocity is its integral. So that's -32t plus some constant. I'm just going to call it c1. Now, it does turn out that we know that the velocity at 0, because this hot air balloon is going up, is basically 16. So what that means is c1 equals 16. So now my velocity function is -32t plus 16. We then move to the position function. The position is going to be -16t squared, just by finding this antiderivative, plus 16t plus another constant. I'll call c2. We are told that the position initially is 64 feet. So what that means is c2 is 64. So now the position function is -16t squared plus 16t plus 64. Now, many people could have gotten to this without going through this whole derivation. but this shows us how calculus can kind of reinforce some things you might even know from a basic physics course. Start with acceleration, we integrate to get velocity. We then pinpoint the c because of initial conditions. Once we have the velocity, we integrate to get position. We can pinpoint what c is because of initial conditions. Ultimately, now we have our position function. Now, this is one I'm not going to complete, but I'll give you some direction. For part A, we basically have to let this s of t equal 0. And just go ahead and find those values. For part B, we're going to find the velocity at whatever this answer is what we put into the velocity. And again, just go ahead and continue that. So let this function be 0. You could use the quadratic formula, factor out -16, factor it if possible. You're going to get a time. When you get that time, you're then going to put it into the velocity function. And that will tell you the velocity when it hits the ground. Last one I'll do in this little segment is from 61, also from section 5.1. Here we have the acceleration due to gravity in terms of meters per second. So it's negative 9.8 meters per second. Same type of thing. Its velocity will be the integral. So it's negative 9.8 t plus some c. Now, we do know that that c is called initial velocity. And I don't know it because that's really what I'm trying to find. The position then is going to be the integral with respect to t of this function, which is negative 4.9 t squared plus its initial velocity times t, which again I don't know, plus 2. Now the reason I knew that was 2 is because the position initially was 2. Now what we're supposed to do is find the initial velocity needed to get this thing up to a height of 200. So what we have are two different things. We want the position to be 200 when the velocity is 0. Now the reason the velocity is 0 is any type of an object that is going up at its highest point, its velocity is going from positive to negative, so it's 0. A little bit of physics intuition. We could also just call it a max, or if we would like. But ultimately, we then have to solve this system of equations. Keep dropping my marker. That's nothing new. So we have a negative 9.8 t plus v sub 0 equals 0. That comes from this. And then we have negative 4.9 t squared plus v sub 0 t plus 2 to equal 200. Now we have to solve this system of equations. We eventually want to get v sub 0, but we might have to find t first. It might be more convenient. My advice is to take this equation and solve for v sub 0, which is basically 9.8 t. We can then put that 9.8 t right here. We're going to have a nice simple equation to solve for t. Once you get t, you can go back and find v sub 0. So these last couple, I've left you with a little bit of work to do, the algebra, but hopefully this is something that will get you started on a few of these from section 5.1. Just a few minutes, I'll post some solutions to a 5.2 and 5.3 problem. Thank you.